All right, hey everybody. So we have a test coming up and making some review videos. So the first one we're going to go over is carrying capacity. So I like to always think carrying capacity is just how many grocery bags can you hold. It's how much an environment can carry. So let's get on to that. Carrying capacity, like I said, the amount of individuals an environment can hold. And this depends on a lot of different factors. Just a heads up, you may see carrying capacity as just the letter K. So just a heads up on that. But carrying capacity depends on a lot of different things. There's three main ones that we're going to cover. One, food availability. If we only have 100 cheeseburgers, we can only feed 100 people. And if we have 150 people, it's going to have to split up the food, and everybody's going to be a little bit more hungry than competition, so you can see where that goes. Two, space availability. So if you actually look over here to the right, we have these two fish bowls. The one on the left is a little packed. The one on the right is pretty good. So the amount of space available, a tiny little island like Hawaii is going to hold a lot less people than the continental United States. And then three, water availability. Water is one of those things we all need to live. So water availability definitely takes into account how many people can be in a certain area. And that's actually something we're starting to see with California with the droughts and everything like that. So carrying capacity, the amount of individuals an environment can hold. Very, very important for this lesson. Okay, so let's keep going. What keeps populations from going over carrying capacity? So all populations stay around carrying capacity, or there's something that keeps them in check. It's called like a feedback system. So there's two types, and we've gone over these: density dependent and density independent. So if you look at the words density dependent, so these are all factors that depend on how dense the population is based on the wording. It's basically these factors come into effect when there's a lot of people. Though the one I like to use is a zombie outbreak, where if zombies outbreak in New York City, it's going to spread a lot faster than if it spreads in Bismarck, North Dakota. So New York City's a lot denser, so it's going to go a lot quicker. And three examples are starvation and famine, so food availability once again, predation and competition. So if there's 1,000 deer and a couple wolves, that's pretty good for the wolves. It's going to lower the deer population. And then disease. Just like going back to the zombie in a real world situation, think about the flu. It's going to go a lot faster through New York City than it would from a rural town. On the right, we have density independent factors. So these are factors that do not depend on how many people are there. They're just going to happen. Hurricanes, floods, volcanoes, earthquakes. So these are the ones that don't care how many people are there. It's just going to happen whether there are people there or not. So remember, density dependent matters how many people are in that area. Density independent doesn't matter. It's just naturally occurring things. A lot of people like to think of these as biotic and abiotic. So if you like to think that way, go for it. Okay, so I really like this picture that I found. So think about the water as the population, and the bucket is the carrying capacity. So buckets can only hold so much water, can only carry so much water. And like I said, think about the water as the population. So as the population starts to grow, these little factors start to pop up: old age, loss of habitat, human development, weather. So you can start piecing these in as independent and dependent, density independent, density dependent factors. So disease and parasites, those are density dependent. Those will lower the population. Starvation and accidents, once again, density dependent. Weather is density independent. If a hurricane comes and wipes out part of the population, it's going to lower the level of the water. So this is just a cool picture that I think shows pretty well how these different factors can affect the total population. So what we're going to talk about next is predator versus prey relationships. We talked a lot about this with the wolf and the deer. So they have a big effect on each other. So if we look to the graph here on the right, the prey population goes up. Think about this as the deer. And then what happens, there's a lot of deer. So the wolves are finding them easier, and the wolves go up. So the blue line is the wolves. So we start to see this little fluctuation, this change, because a lot of deer come about, and then a lot of deer die because they're getting eaten, and back and forth, back and forth. So remember, too many deer and they are sick and dying. When we introduce wolves into the population, it starts to level out. So now we have fewer deer, but they're healthier. So this is a density dependent factor. The wolves and eating deer depend on how many deer there are. So lastly, the things you really want to know, carrying capacity. You have to know that. Predation and how it affects populations. I mean, it affects populations quite a bit. It declines their numbers, but it also keeps their numbers healthy. If there's only so much food and you have a lot of deer, those deer are going to be sick. But now there's a lower population of deer, then they're going to be healthier. No density dependent and density independent factors, be able to identify some of them, and then how so many of these factors affect the size of a population. So be able to tell me how density dependent and density independent factors affect the size of those populations. So if you didn't get all this, go back, rewind. I know I went really quickly, but that's the beauty of these videos. Pause, rewind, go back. If you have any questions, shoot me an email on Schoology, and good luck. Move on to the next video.